So in this video, we're going to find the surface area of the solid form by rotating the function f of x equals x cubed over 3 from 0 to 1 about the x-axis. So what does this look like? X cubed looks like this. And now x cubed over 3 is just going to be flattened out a little bit more. So I'm going to clear this out here. So, kind of like, oh, it's not what I wanted. Okay. Now, what are we doing it? We're only doing it from 0 to 1. So from 0 to 1 maybe looks like this. So I'm going to stop here at 1. So from 0 to 1. And I'm going to revolve it about the x-axis. So basically, I've got this shape that looks like this. Okay, so this little cone-looking thing in here. And I want to find the surface area of that shape right there. Okay? So how do we find that surface area? Well, the formula, we think about our cuts. How are we cutting? It looks like a dx cut will be our easiest cut. So surface area equals integral from a to b, 2 pi f of x square root f prime of x squared plus 1 dx. Okay? So I see a f of x, that's kind of where I'm jumping to. I write my f of x there. I need to also find the derivative. So f of x is x cubed over 3. So f prime of x is well, I bring the 3 down, subtract 1 from it, and so that gets me x squared. So my derivative is equal to x squared. So where am I integrating from? Well, I start at 0, so my a is 0, and then I finish at 1, so my b is 1 there. So the integral from 0 to 1, 2 pi f of x, which is x cubed over 3, square root the derivative squared plus 1 dx. So this is equal to the integral 0 to 1, 2 pi over 3, x cubed, square root, x to the 4th plus 1, dx. Now, at this point, if you wanted to, you could do your calculator. I'm just going to go ahead and do it because I see a u substitution here. If I make u equal to x to the 4th plus 1, du is 4x cubed dx. And I see an x cubed dx right here. So I'm going to take out that 4. I'm going to divide both sides by 4. And so I get 1/4 du equals x cubed dx. So this is going to become 2 over pi, 2 pi over 3 integral. And I'm going to replace x cubed dx with 1/4 du. And then replace this with u, so the square root of u going in here. Simplify this a little bit. The 2 and the 4 cancel, so I get pi over 6 on the outside. Integral u to the 1/2 du. U to the 1/2 becomes u to the 3/2 times 2/3, then pi over 6. Okay. So that's going to reduce. That's going to be pi over 9. And u, remember u was this here, so that's x to the 4th plus 1 to the 3/2, evaluated from what? 0 to 1. Okay. So if I evaluate from 0 to 1, that's going to get me 1 plus 1 to the 3 halves, and then minus 0 plus 1 to the 3 halves. So that's 2 to the 3 halves, which is 2 square root 2, and then this is just 1. So I have 9 pi times 2 root 2 minus 1. Okay? So 9 over pi, let's see, I'm sorry, pi over 9. So I'm going to do second pi divided by 9 times parentheses 2 root 2 minus 1, close parentheses. So 0.638. Okay, so let's show you once again how to do this in your calculator. So when you got to this point here, you could have done this in your calculator. So if you did this in your calculator, I'd go to math and then 9, and I'd go from 0 to 1, and then I would have a square root of 1 plus x to the 4th. Okay, but I also need to count, is it going to let me go in there? There we go. So I got a 2/3 or a 2 pi divided by 3 factor going on in there, and also have an x cubed going on. I think that's it. Oh, what do I have? What's wrong with that? Why is that wrong? Let's try it again. See if we can do it. So math 9, 0 to 1, and then I have parentheses 2 pi divided by 3, close parentheses, times x raised to the 3, and then times square root x raised to the 4 plus 1, close parentheses. Hopefully this works. Okay, good. And so we got the same thing, 0.638. All right? So once you get to this point and it's simplified, as much as you really reasonably can simplify, if you want to just write out that answer, that 0.638, that's okay. Unless I tell you, show me all your work to get to your answer. If I say that, then that means that you do have the integration technique to get the answer, right? So it might be difficult, but it is definitely doable. All right, let's try one where we actually revolve, instead about the x-axis, let's revolve about the y-axis. So find the surface area of the solid. Oh man, okay, so I'll spell it right here in a second. Formed by rotating x equals the square root of 2y minus 1, 5/8 y to 1 about the y-axis. Okay, about the y-axis. So since it's about the y-axis, we need to use our formula, okay? So our formula about the y-axis, surface area is equal to c to d 2 pi g of y square root g prime of y squared plus 1 dy. Okay? So if we use that formula, what's going to happen? Well, I need to know what g of y is. G of y is the function square root 2y minus 1. Now, this is 2y minus 1 raised to the 1/2 power. I write it that way because it helps me get g prime. So g prime, I take the derivative, I bring the 1/2 out. Remember, it's a chain rule. So I take the derivative outside, so 1/2, 2y minus 1 raised to the, we'll take away a half, or 1 away from a half gets you negative a half. And then multiply by the derivative of the inside. What's the derivative of 2y minus 1? That's just 2. So multiply by 2 here. So what does this get me? It gets me 1 over the square root of 2y minus 1. Okay? So what does this become? This becomes the integral from what? Well, c to d. So 5 over 8 to 1 of 2 pi square root 2y minus 1 times square root of, oh my goodness, 1 over square root 2y minus 1 squared plus 1 dy. This is why it's important to simplify before you do anything else, because if you don't simplify, golly, your life is just, I mean, this is tough. It's tough to write into your calculator. So let's do some algebra here. I'm going to pull the 2 pi out, integral 5/8 1, and then I have this. I have the square root of 2y minus 1, but here I have another square root, but this is all squared. So that becomes 1 over 2y minus 1, square and the square root cancel, plus 1. Okay? It's not bad. Dy. I can actually combine this. If I make this 1 here, if I make that 2y minus 1 over 2y minus 1, then I can combine these numerators to get me to 2y over 2y minus 1 in the square root. Okay? So all of this simplifies down to that. So I have dy here, square root 2y minus 1, integral 5/8 to 1, 2 pi. And since these are both square roots and I'm integrating from y values from 5/8 to 1, I know that both of these individual pieces are positive, so I can combine this to one radical. So that's 2y minus 1 times 2y over 2y minus 1 dy. Okay, why is this good for us? Well, now this factor and that factor will cancel, and I literally get 2 pi integral 5/8 to 1 square root 2y dy. How about that? That seems a lot easier, right? So you can integrate this. I'm going to factor the constant out here. That's going to get me 2 square root 2 pi on the outside. Now, square root of y becomes y to the 3/2 and 2/3 whenever I integrate. And I go from what? I go from 5/8 to 1. So this is going to be 4 root 2 pi over 3. And then I have 1 to the 3/2 minus 5/8 to the 3/2. Okay, this will reduce 4 square root 2 pi over 3. 1 minus, golly, that's disgusting, of square root, we'll just multiply it out, right? So that would be 5 cubed over 8 cubed which is 5 root 5 over 8 root 8, which is actually 2 root 2. So that's 16 root 2 in the denominator there. Okay. This is just algebra here. I'm not asking you to get crazy like I'm getting here. So that would be... So that would be 4 square root 2 pi over 3, and then 1 minus 5 square root 5 over 16 square root 2. If I multiply through, I get 4 square root 2 pi over 3 minus pi over 3 times 4, and then 5 root 5 here. So if I multiply by 4 and 4 here, so that's 16 root 2 pi minus 5 root 5 pi over 12. Okay, that's totally disgusting. So, you know, who cares if you get the exact answer here? What I would do at this point is I would put this into the calculator. So if you put that into the calculator, you get math 9 and go from 5/8 to 1 of the square root. And instead of 2y, I'm just going to put 2x since I already have a dx here. And I get 0.477, assuming that I didn't screw up my algebra somewhere, which is entirely possible, right? So that would be the answer at that point. Okay. Now, say you wanted to do that problem, and instead of using the formula SA equals 2 pi, or integral from C to D, 2 pi g of y, you know, all that stuff with respect to y, say you wanted to do it with respect to x, well, what is that formula there? Well, that formula with respect to x was what? It was integral C to D of what? 2 pi x square root 1 plus dy dx squared dx, right? Well, the problem is my function right now is x equals square root 2y minus 1. To get a dy dx, I need y equals. So if I square both sides, add 1, x squared plus 1 equals 2y, and then divide by 2, now I have y equals x squared over 2 plus 1/2, okay? And to get dy dx, I take the derivative with respect to x, and I get x. Not hard. And so what does this become? It becomes integral C to D. Now, instead of it being 5/8, you know, y equal 5/8 to y equal 1, we change the bounds, right? So if I change the bounds, if I plug a 5/8 in here, what do I get? I get 10 over 8 minus 1, which is 2 over 8, which is 1/4. Square root of 1/4 is 1/2. So this gets me an x equals 1/2. And then 1, if I plug a 1 in, that's 2 times 1 minus 1. Square root of 1 is 1. Okay, and then it's 2 pi x square root 1 plus, what's the derivative it's x, so it's x squared dx. So this should get me the same answer as long as I didn't screw anything up. So let's try it out, see if we can get the same answer. So integral from 1/2 to 1 of 2 pi. Uh-oh. All right, on that last one, I forgot to put the 2 pi in there. So that's why I got a little bit different answer. So I'm going to leave out the 2 pi off of this one, so bear with me for a second. So x and then square root 1 plus x squared. Okay. All right, and as you can see, you get the same thing, so 0.476. Now, remember I noted here that I had left off my 2 pi, so I need to multiply that answer by 2 pi, so times 2 times pi, and when I do that, I get the 2.9968 going on here. Okay, so that's good. So 2.997 is what I had in my notes, and I was like, well, I guess I made a mistake, but turns out I should have just trusted myself. All right, so don't forget your pie, all right? Most important part of the meal, right? Eat your pie. All right, one more problem, and we'll be finished with surface area, okay? So find the surface area of a solid formed by rotating y equals x cubed from 0 to 2 for x values about the y-axis. About the y-axis. Okay? So if I'm rotating about the y-axis, there's two formulas that I have. What are my two formulas? Either I'm integrating with respect to y or I'm integrating with respect to x. Now my function was y equals x cubes. So y equals x cubed, that's dy dx in terms right there. So I'm going to use the second formula here, okay? So that's what I'm going to do. I'm going to use the second formula because I already know my function is defined y equals f of x. Here, this is x equals g of y. Okay, so if you had some x equal to g of y, then you'd be good to go. But in our problem, I had y equals x cubed. So that's more set up for the second formula. So that's what I'm going to do here. I'm going to use the second formula. Oh boy, might take a while, but we'll get down there. Okay. And so all I need now is I need dy dx, which is 3x squared. And so this is the integral from what to what? Well, if it's with respect to x, that's x equals c to x equals d, right? So we already have our x values given to us here. So from 0 to 2 pi x, we'll just write the x, I mean, it is what it is, square root 1 plus 3x squared squared dx. And you type that in. Okay, so 2 pi integral 0 to 2 x square root 1 plus 9x to the 4th dx. And I'm just going to go straight to my calculator. Let's clear this out. So 2 pi math 9 0 to 2. And then I'm going to do x square root 1 plus 9x to the 4th. Boom. enter, and I get 6.2831. Wait a second. That doesn't seem right. What did I do wrong there? Because that seems like 2 pi. Let me check my theory. Yeah, okay. Let me try to do it separately. Maybe this calculator won't do both at the same time. I don't think that's 1. Let's try this again. X and then square root 1 plus 9 x to the 4th. I mean, maybe it is 1. No, it's not. All right, so that's 12 and some change times 2 times pi. So you have to multiply it out separately, but you get 77.325. Okay? All right. If you got any questions, as always, shoot me an email and I'll be glad to help you out. Whether it's how to use your calculator to get this, or how to use the different forms of the integrating with respect to y or with respect to x when you're rotating about the y-axis. Okay.